is Richard Ho from Google. Richard received his PhDs in computer science from Stanford University. He was a co-founder of Zero Inch Design Automation and an early technologist involved with assertions, formal property verifications, and the CDC verification. Richard was also part of the team that built the Nton and Nton2 supercomputers for molecular dynamics simulation at the eShaw Research. He's currently part of the data center chip team at Google, working on TPU and other cool projects. So today he will talk about how to build a sustainable open source hardware ecosystem. Thank you, Richard.
Thank you for the introduction, and thank you for the invite to speak. This is a distinguished set of speakers you have here. I'm very honored to be among them. So today I'm going to wear two hats. One is a Google hat to explain kind of Google's take on open source hardware and kind of our approach to it. And my second hat will be as a board member of Chips Alliance, which is an open source hardware foundation that has just recently launched. Okay. So first of all, Google. When you think of Google, I think there's a lot of services that are kind of that come to mind. Many of these that I kind of have the icons up here have 1 billion plus users. So we're talking big scale products. And a lot of them have, hardware requirements that go behind them, right? So a lot of these services are backed up by our infrastructure. And that demand for that infrastructure is growing quite fast, and it's growing very organically. So these numbers, and most of the numbers I have are from 2016, which is what I could get authority to release to you all. But this shows kind of the YouTube upload rate, right? And the y-axis is indeed logarithmic. Is exponential. And so you can see that the number of minutes being uploaded, the number of hours actually of video being uploaded per minute is growing very, very fast. And all of that requires a lot of communication and the ability to store that and the ability to transcode it between what the users actually upload and what we actually store in our own format there for space reasons. This is also, the growth is also true in terms of features. So this is kind of a nice graphic that I borrowed from Partha sitting over here, which shows kind of the features in search that has been increasing in Google since search was introduced back in the late 90s, right? First of all, if you remember, it was a very clean web page. It was almost all white, just a single box. It was very beautiful, but it has since gotten much more complicated, right? So there are now autocompletes. So the system is trying to figure out what the user is asking for and tries to put it in. There are special search results. So there's a box that comes up that might be optimized for like the World Cup results, the Women's World Cup results that are going on right now. There's a special box that will come up if you search anything kind of related to that. And there's lots and lots of little things, many of which are actually invisible to most of us, or at this point we take for granted. There's a lot of features that we don't even realize have been specially put in there for us that have a lot of complex data movement, a lot of complex algorithms that are actually backing it. Here's another example, right? Maps. This used to be very simple. It used to be just an image of kind of something that you get out of a paper atlas, and it would have like a little red pinprick of the place that you asked for. It has since grown in terms of the metadata and the information that's provided, right? Satellite imagery is now layered on top of it. There are photos. There are street view photos. There's information about businesses. Lately, there's been real-time information, traffic, right? News, weather, all of that information comes into that product and makes it a lot more interesting. And finally, I think in the world of social networks, there's now personalizations and information about where your friends are, your nearest neighbors, and of course for Google and other companies, there's also monetization ads that go on top of all of that. So the demand is growing. Here's another example, my final example, right? There's some data that is in the data centers. We have photos, but now with the advent of better ML and AI algorithms, we can actually extract a lot more information from this data, right? We can actually extract information about businesses, the address, even dynamic information about the traffic patterns that are going on there. So, data is growing, and I'm at ISCA, so this is the mandatory graph that everybody has, and I think you've seen this multiple times today already. The ability to address this compute is slowing down naturally, right? And so what has Google done about it? Well, In the early days of Google, this is a picture of the Lego server that Larry Page, I think, had in a garage, I think back in '96, that they used to kind of surf the web and collect links and web pages and bring it all together. So Google has kind of in its DNA, right from the very beginning, the urge to design its own hardware, right? And we went ahead and we did do our own hardware when this kind of compute need became obvious, right? We've announced various versions of the Tensor Processor unit to address different ML workloads. The reason this came about was, I think it was back in 2012 or 2013. Various people, including Jeff Dean, noticed that if everybody's using 3 minutes to translate on an Android phone, we would have to double our number of data centers. This story's been told many times before. And so it was necessary to actually accelerate a lot of the workloads that are in the data centers. So from that, why open source hardware? Well, we've gone about and made a ton of designs, many of which have been announced already. But we actually see that open source hardware is a way to accelerate and keep this cycle of innovation progressing forward, right? And the real key to it is not that open source hardware is cheaper or free, right? Open source, but open source is really about innovation. Our vision here is that if you're able to quickly build the domain agnostic parts of your designs, your SOCs and things, and really focus on where your innovation comes from, your quote unquote secret sauce, it helps everybody, right? And I think we've heard from many people today about that, that possibility. And so this is our kind of hope to be able to build on the computer architecture renaissance that's due to the end of Moore's Law that's coming about. At Google, there's been a long history of engaging with the open source, almost exclusively in software. 10 plus years of projects, and I think it's been said internally many times that Google would not have succeeded without open source software, right? And so it's a part of the DNA to support open source. There's constantly a stream of contributors in all, the GitHubs of the various projects that are around and various projects. And so it is part of what we do, okay? However, I think it's pretty clear that there's a difference between the open source software world and where open source hardware is today. Today, it's kind of a case where people dump their projects into a GitHub somewhere, and if you're lucky, it gets used, but quite often, a lot of projects don't get used. Unlike the open source software community, where there's actually, active collaboration, there's active contributions, and people build on top of it in a very meaningful way to get to a place where many of these projects are the basis of commercial companies, okay? And that's, I think, one of the key themes I'm going to come back to today is about this building of a community that involves the commercial interests, okay? On the hardware side, there are many barriers to entry, right? Fabrication at the bottom there, the kind of the PDKs, we heard some questions about the closed source PDKs. That's going to be a hard one to crack, I think, right? There are some open source PDKs. I've heard of a fab called XFab, in answer to Andrew's question before, that I think has an open, okay, he's shaking his head. I don't know too much about that, but there have been efforts to try to move in that space. But there are a lot of barriers to entry, including engineering, the IP, the tools, and infrastructure. The EDA industry has been very resistant to it. And the IP companies have been built up a pretty good business around, providing closed source IP to the large SOC, commercial companies. And so, given this, a group of companies, a group of individuals, and some organizations got together over a course of a period of time that really came from the RISC-V Alliance. There was a lot of early people in the RISC-V Alliance who said, okay, we have an open ISA. We want to move forward into actual RTL, actual IP that people can reuse and actually implement silicon with. And so we formed this group called the CHIPS Alliance. And CHIPS is an acronym for Common Hardware for Interfaces, Processors, and Systems. And it was announced back in March. I'll talk a little bit about the kind of organization of it a bit, but let me talk about the goal first, right? So the goal of CHIPS Alliance is to provide a curated, high-quality, open-source hardware code. We believe that this is doable only with the support of an ecosystem that has software tools, verification, and documentation. I think it's really critical that it's not just a repository or a foundation for the RTL, but it actually tries to address all the things needed in order to turn that RTL into a viable SoC that actually has legs, right? You can actually use it for meaningful things. And most importantly, the CHIPS Alliance is meant to be a barrier-free environment for collaboration. And part of that, I think we haven't talked about that here, and I'm not sure that's, because it's a more academic focused workshop, we haven't talked about licensing and IP requirements, right? And that's one of the things that actually the CHIPS Alliance tries to address upfront and be very clear about, because if everyone's playing on the same level playing field, it kind of aids the collaboration going forward. So who are in it? So it's a small number right now, but it is growing quite fast. There are 1, 2, 3, 4, 5, 6, 7 companies already in. Google, Western Digital, they're kind of the big kind of public companies. A couple of smaller private companies and individuals as well, right? We have Wilson Snyder, who is the author of Verilator. And we have Olaf Königren, who's doing some SoC kind of design tools there. So it is an organization that is trying to reach out across the globe. I would also say one thing, which is it's not only a RISC-V organization. It's heavily RISC-V, but with the goal of trying to establish an ecosystem that kind of deals with SoCs, it has been explicitly chartered to not be just RISC-V. You can have a controller there that can be used with an ARM core, for example, or a power core, right? You can have interfaces that deal with the other things. But I would say that because RISC-V is an open source ISA, a lot of the work is very RISC-V centric because of that good thing. And I think we saw earlier that matrix that Dave provided about licensable, open source, and closed, right? And CHIPS Alliance is really aimed heavily at the totally open source and with some good benefits to the licensable domain as well. Okay, organizationally, it looks a lot like any other kind of open source foundation. There's a board of directors who currently we have Yunsep from Sci-Fi. We have Zvonimir Bandik, who's the chair from Western Digital. Dave Ditzel, who's the CEO and founder of Esperanto, and I think he's done a lot of work in CPUs in the past. Myself as a vice chair, and we're adding more board of directors. Even as I speak, there's votes going out on email there. We have an interim director, Ted, who's actually the marketing director of RISC-V Foundation as well. And the organization is set up to have a technical committee so that projects can actually apply to be supported through this organization. And the chair of that technical committee is Henry from Sci-Fi right now. And then each project will be maintained separately, and we'll also have an outreach group because, as Young Gong mentioned, marketing and outreach to the community to increase the awareness and viability of the ecosystem is a very important ingredient of open source. Right? So the governance model, actually that's very similar to what I just said, so maybe I'll skip over that. But there's a word of governance, yeah, okay. So key, membership. So like other projects of the Linux Foundation. Oh, yeah, I forgot to mention that actually. This is, CHIPS Alliance is actually a project within the Linux Foundation. So the Linux Foundation obviously came about through open source software for Linux, but it's actually expanded out. And the key things here is that it has already established a lot of the governance and IP rules that are useful for open source collaboration. One of the key things that we have is we have standardized around the Apache v2 license, which is a permissive license. And maybe I'll say a little bit about that, right? So I think there has been argument in the open source community about copyleft versus permissive. I think the key thing here is that in order to get corporate involvement in open source, you need to have a permissive license. And that's a very important point, which is that if there is a copyleft license on a piece of open source code, corporations will not touch that code, right? It is against policies for many, many corporations, if not most corporations, to touch that code. And so if you want to get collaboration, if you want to get input, you want to get usage of it, it unfortunately has to be permissive. But then what you're getting is the ability to have engagement and the ability to have kind of collaboration. So, I think, Dave said this, or I can't remember if it was Dave, someone said this earlier, which was, don't force the collaboration through licensing, right? Force the collaboration, allow the collaboration to occur through openness and through providing something of value to everybody, and then have that community come back to you. There are membership levels. I would stress, especially for this community, the academic level is free. So we do want to have academic engagement in CHIPS Alliance, and I think that is really one of the most important things is to be able to bring together industry, individual collaborators, academia, in an open source group. So this foundation launched on Wednesday. This was 4 days ago. This is at the Google Sunnyvale office. There were well over 200 registered and/or waitlisted attendees. I might be biased, but I felt the energy level of the discussions was very high. There was a lot of enthusiasm from a lot of different parties. This is one of the shot there. I think we've hit a knee in kind of the open source hardware, where at one point open source was kind of like not looked at as being very viable in the hardware world. But I'm beginning to see, and I think a lot of this credit goes to the RISC-V work that's gone on, that the people in the companies as well as in academia are really looking for this as being a way to actually create real chips. Okay, I'm going to spend a bit of time on this. Okay, so I had said that to get the ecosystem to really be viable, you have to provide more than just the RTL. So this is a list of some of the things that have been contributed already or were mentioned and presented at that workshop that sort of shows you the kind of range of stuff that we're dealing with, right? So at the top, there are indeed open source hardware designs. There's the Rocket Core is moving from UCB over into CHIPS Alliance. And then there's a Swerve Core, which is Western Digital's RISC-V core that they intend to deploy into their disk drives. And they've made a statement, a very bold statement, to say that they will be shipping over 1 billion RISC-V cores of these open source cores, in the near future. There are networks and interfaces. There is TileLink that came from the Berkeley work with Rocket Chip. But there's also this new standard, a new format that's being extended for chip-to-chip communication that's based on TileLink, but Western Digital and other companies are adding to it. Other important parts, there are design tools that we're talking about, right? So Chisel, Fertile will be in CHIPS Alliance. There is this thing called Fuse SoC, which is an IP package manager that has been contributed. Sci5, Yunsep announced a new workflow for SoC creation called Federation, I believe. And also we had a talk from a startup company about an analog generator, design generator, right? I think there was an earlier question about analog IP. Can you do it? I don't know much about analog. I was kind of fascinated by this generator that is open sourced and is being brought in, right? And then another important part of this, which Younggang mentioned, which is, in order to use this IP and these flows, it's really important to address RTL simulation and design verification, right? I think, one important thing is that, if you've tested this IP in one instance, in one place where you've kind of like put it in SoC and it kind of works in one place, it's okay, but is it really IP? It's not really IP until you kind of, tested it for all possible contexts and all possible interactions, right? And so, me as, with a verification background, I feel this is really important, and that's one of the things I've been stressing on, is to make sure that, this foundation really provides design verification collateral so that the community can actually make use of this IP. And so, we at Google, we've donated our very stressful instruction generator, and I'll spend a few minutes if I have time to tell you a bit more about it. Verilator has been brought in. So Verilator is the open source Verilog 95 simulator, and Wilson did talk about his roadmap to try to extend it out into UVM to make it a fully compliant, like IEEE 1900 2012 simulator. And we also had a contribution of a Python test bench so that you could actually run your code with Verilator because it doesn't use UVM, right? So all of these things, address a very critical part of that. And I was really excited to see these verification collateral being contributed into this open source community, because I feel that's one of the major things that have been missing in prior open source hardware efforts. So I'm going to move on a little bit and talk about our contribution, Google's contribution, just for a few minutes here. So, I feel that quality is the key to reuse, and we need to stress test that, right? We want to build on a strong foundation. We don't want to have a weak foundation. DV accounts for more than 50% of project times of complex chips in industry. I know in academia, the testing seems to go really fast, but I'm telling you, when you want to take this thing out and you want to go production, you need to spend a lot of time on DV, right? So it's kind of the foundation for reuse. And so, there have been some good open source RISC-V processor verification solutions, which is what we were looking at the time. Things like stress testing through torture, and there's a risk compliance test that's available. But I think that's one of the differences between academic view of verification and industry view of verification, is that we think that you need to go a lot further than that. And so we really identified a lot of missing pieces in what was available there, including stress testing of branches, branch prediction, memory management, exception scenarios, and so on, right? And that gave us the motivation to build a very high quality DV infrastructure that we then could open source to the rest of the community. And that's what we did, right? So I don't know who here is a fan of Top Gear, so if you know Top Gear, you know what I'm talking about. But our stressful transaction instruction generator will really drive your RISC-V core through corner cases and push it to the limit, right? That was the intent of it. We open sourced it, and it's going into Chips Alliance there. And it's built on System Verilog and UVM. Some of the key features, which I'll go through very fast, right? It's much more random than just randomness sequences, right? It actually randomizes at the instruction, kind of the template level, where we're dealing with branching forward, branching backward, kind of page misses in memory, and things like that. So it's architecture aware, it's very high performance, and it's extendable. And here's a set of feature lists. Very importantly, we've made it a big effort to support different cores, run on different cores. We've made a big effort in order to support different simulators and different kind of golden reference models, right? And so here's a typical flow. And I want to highlight this for a couple of reasons. One is that it's a collaboration of many different companies, right? And it's a collaboration happened in the open source. We didn't get together and do it kind of closed. We did it together with open source. And again, kind of tying back to Younggang's presentation just a minute ago, we're doing this on cloud, right? So the effort to get onto here is very easy, right? You can just go to, in this case, our cloud instance, and just start it up in a few minutes with very low cost. And what we demonstrate here was really our instruction generator running through a cloud simulator. In this case, we partnered with a company called Metrics that does a cloud simulator on Google Cloud. And we partnered with a company that provides a golden reference model. It's basically a C model of the cores. And we ran a verification end-to-end on this in a collaborative effort out in the open. So in summary, we think open source hardware holds lots of promise for greater innovation, and that's really where we want to focus on the innovation. But we think that a healthy, sustainable ecosystem needs collaboration between industry, academia, as well as grassroots. And that's the key difference between where open source hardware has been and where we see open source software succeeding, right? So Chips Alliance aims to support this through curated high-quality projects that are used and maintained. I think that's the key thing. It has to be used, has to be maintained. So this is, in fact, an invitation to get involved and trying to reach out to the academic community and to ask for your involvement. So with that, I say thank you and open for questions. The question was, are there open source emulator systems? And by emulator, do you mean hardware emulators? Or do you mean like virtual prototyping?
Chip emulators in which the hardware and firmware can be design tested together.
So you can do it through software. So like our partner there in Paris actually provides what's called a virtual prototype. So it will emulate, so you can develop your software on it. It runs in simulation, but runs it much faster than RTL simulation, but it's not hardware assisted. So it's not like a Cadence Palladium or a Mentor Veloci or something like that. So you can develop on it. It runs much faster than RTL simulator. And so that is available. It's not open source, but the models are open source. So, it depends on what So I think there's this fine line still where companies are trying to still find a way to have a business model while supporting the open source community and environment. And in Paris is one example there, where they've open sourced as much as they could, but they've kept kind of the core engine as their revenue generator. And we're going to see, I think we're going to see an evolution of this, where more and more stuff will get open source, but maybe not all of it all at once. Yeah.
Through your CHIPS Alliance hats, have you seen any of the companies or academics sort of push back on the patent grant portion of the Apache license?
Not yet. So that's a very important part of kind of the foundation, where members basically are agreeing to not, sue each other for patent reasons, right? And that's an important reason for being in the alliance.
I can see companies wanting that in there if they go to use a piece of hardware, at the same time they may not want to always contribute, or even academics, not necessarily.
Yeah, so people are free to contribute what they want to contribute, right? So, that's the reason for a permissive license, right? So, you don't want to contribute something and then have a license to a lot of other stuff, or be forced to open source a lot of other stuff.
Thanks, Richard, again.